Alright, time for a pro tip lecture on plotting the normal curve in Excel. So let's go to that link and let's see if we can show what the normal distribution for the MBA grades that we've been using so much actually looks like. And we're going to do that by using a combination of a line and an area chart here in Excel. So the x-axis is going to be for the x values, in this case the MBA grades. So I wrote them out here from 60 to 100, and it's best to be as granular as possible. I did it in 2 by 2 so that they do fit nicely on this screen here, but you can do it 1 by 1 as well if you want to. So that's the x-axis. Now we just need the height of the actual line across the y-axis, or the probability density. And this is where the false argument in the norm.dis function actually comes in handy. So let's create our first norm.dis function. We want to find the height of the curve at this grade for a normal distribution with this mean. I'm going to fix it with F4. And this standard deviation. Fix that with F4 as well. And this time we actually do want to use false because we want the height of the curve because we're going to plot it. Close that, press enter, and let's apply this down for the rest of the grades. So now I'm going to select a blank cell here and go to insert a line chart. And let's select the data that we want to plot. Let's add the series for the probability density. Select the values. Press OK. You can already see the bell shape start to form. Let's just edit the axis labels for the x-axis and select our grades. Press OK. Press OK. And perfect. So this is the, let's change the title, distribution of MBA grades. I'm going to press enter, in which x follows a normal distribution with a mean of 80.17 and a standard deviation of 6.17. Let me add some axis titles here. This is the probability density. This is the x values, or MBA grade. Let me remove these grid lines. And we have our normal distribution curve. So that was easy enough, but adding the area underneath is the fun part. And the trick is to write an if function that returns this value whenever you do want to show the area, and then a 0 whenever you don't. So for example, if we wanted to show the area, under 74 maybe, we write if this is less than or equal to 74, then return the probability density, otherwise return 0. Close the if function, apply it down. You'll see that all the way up to 74 we do get the probability density. In this case we're going to make it an area here, and then everywhere else we get the 0, so we're not going to show it as a shaded part. And to add this, we're going to use an area chart. So let's select this. Go to chart design. Let's select data to add this new series. These are the values. Okay. And let's use the same x-axis labels. Press OK. Press OK. And I'm going to change the chart type to a combo chart, in which the probability density is a line and the cumulative probability is an area chart. Let's press OK. I'm going to edit this line right here. And let me make it a smoothed line. And then let me change this color so that it matches this blue. Solid fill. And let's add some transparency of 80%. So we're almost there, but the problem is that you'll notice that it goes from this height right here at 74 and then to 0 at 76 in this diagonal line, instead of going straight down, which is what would be ideal. So to fix it, what we can do is actually use a negative value for this instead of 0 that's so far down here that the line from here to there actually kind of passes through the 74 instead of the 76. So let me go back to my formula and change the 0 to a negative 100. Let's apply this down. It's going to mess up our chart at first, but let me just fix my y-axis so that it always starts at 0. And look at that. Much, much better. We can even hide these numbers since they're not really adding much context. Let's just change the labels to none. We can remove the probability density label as well if we want to. And we can even use an AND function here. Let me write AND. If we want to show the area between two values. So say we wanted to show between, 72 and 86. So it's going to be if, and then we need two conditions to be met. This to be greater than or equal to 72, and this to be less than or equal to 86. Close the AND function, press enter, apply this down, and there we go. Pretty cool, right? Granted, not necessarily a practical application, but sometimes it does help to visualize a distribution like this to get a better sense of the probability you're trying to calculate and what you need to do to get it. In this case, it would be this area right here minus this smaller area right here. That would get us this area in between. Okay, so now we know how to calculate cumulative probabilities for any given x value or z-score. But if a variable follows a normal distribution, you can also estimate the value of x or z at a specified cumulative probability. So it's basically the other way around. If I have a normal distribution like this one, in which the area right here represents a cumulative probability of 75%, for example, then I can calculate what the value would be right here along the x-axis. And this comes in really handy to calculate values for any percentile in a normal population, and we'll use it later as well when building confidence intervals. Alright, so norm.dist helps us calculate probabilities based on x values, and norm.inv does the opposite. The norm.inv function returns the x value in a normal distribution at a specified cumulative probability. So if we look at its arguments, we have the cumulative probability for the value that we want, and then the mean and standard deviation that describe the normal distribution of the population that we want to get the value from. And to continue with the theme of possible questions, we could answer something like, how tall do you need to be taller than 80% of Olympic basketball players? Again, we have our normal distribution of basketball player heights, and we want to find the height at a cumulative probability of 80%. So we can plug these numbers into our norm.inv function, and we get 203.8 centimeters, which is the answer to our question. So in other words, 80% of Olympic basketball players are 203.8 centimeters or shorter, or to say it in a slightly different way, if we were to grab an Olympic basketball player at random, then the probability of him being 203.8 centimeters tall or shorter is 80%. And that's all there is to it. So let's head over to Excel now and look at an example with our project. Here in Excel, I'm going to jump to the link on estimating values with norm.inv. And we want to see the grade range that we can expect the middle 50% of graduates to fall within. So we actually need to estimate two values here. The middle 50% goes from 25% to 75%. So we need the grade that falls in each of these two cumulative probabilities. So let's use norm.inv. The cumulative probability for the lower grade is going to be 25% with this mean and this standard deviation for the normal distribution. Let's fix both of these. Press enter, we get 76, and if we apply this down, we get 84.3. So that's it. We know that half of the graduates will get grades between 76 and 84.3, which also means that 1/4 will get grades beneath this, and 1/4 of the students will also get grades above this. Time to go over the norm.s.im function, which by now you can probably guess what it does. The norm.s.im function returns the z-score in the standard normal distribution, or z-distribution, at a specified cumulative probability. And we actually only have one argument here, which is that cumulative probability for the z-score that you want. Since again, the mean will always be 0 and the standard deviation will always be 1 for the z-distribution. So a possible question here would be, the top 5% of Olympic basketball players are how many standard deviations taller than the mean? Well, this is the standard normal distribution, and we want to find the z-score that lies at the start of this 5% top area here. So in the norm.im function, we would write a probability of 1 minus that 5%. Why? Well, remember that the cumulative probability starts from negative infinity. So for the top 5%, the probability is actually 95%, as we can see in the white space of our chart. And the answer in this case is 1.64 standard deviations from the mean. Now let's head over to Excel and look at another example. I'm going to go to the link on estimating z-scores with norm.s.im. And we want to see how many standard deviations away from the average MBA grade the bottom 20% of graduates are. And in this case, the probability is that 20% since we are looking at the bottom 20% of graduates. So let's write this 20% here. And to obtain the z-score, then we use norm.s.im. We just add in this probability, press enter, and we get negative 0.842. And there we have it. You don't even need to be one full standard deviation away from the mean MBA grade to be in the bottom 20% of the graduates. Okay, time for the final assignment of the section on estimating values for normal populations. Molly's replied to us on the same thread for the honor students, and it looks like she's going to stick with the grade of 90 as the threshold for the honor students since it didn't go over the 10% of the students that she was afraid of. But she is curious though. What grade would put students in the top 10% of the class? And how many standard deviations away from the average student would that be? She also wants you to know you're crushing it, by the way, as do I. But before we get ahead of ourselves, let's look at the key objectives for this one. Number 1, use the norm.im function to calculate the MBA grade for the top 10% of the class. And 2, use the norm.s.im function to calculate the z-score for the top 10% of the class. So get to work.